Good afternoon and welcome to Agrifood Conversations brought to you by iSelect, the Van Trump Report, the Yield Lab Institute, and Family Farms Group. My name is Luke, an associate on the iSelect Fund team. Agrifood Conversations is all about driving innovations in agriculture. Each month, we highlight a specific theme, including emerging topics such as soil health, plant genetics, vertical farming, and aquaculture, to name a few. This month's theme is crop harvesting and food processing technologies, and we have been exploring different companies and angles that show promise in this field. Today, we are joined by Francesco Amini, CEO and co-founder of Induction Food Systems. Induction Food Systems helps food and beverage manufacturers improve efficiency and expand production with on-demand precision heating equipment. The company's technology uses electromagnetic energy to create the first scalable, precise, and efficient inline heating solution for a wide range of fluids, including high viscosity and particulate foods. IFS's inline heating platform increases manufacturers' yields and uptime and displaces legacy steam heating systems with smart, sustainable solutions. Each of you knows companies are more likely to succeed with the right network of customers, talent, investors, and advisors. We've invited you to this call because you are some of the smartest, most talented people in the Induction Food Systems market. You are potential customers for Induction Food Systems products and services. You built and sold a company in the agri-food industry, or you are a sophisticated business person who understands the agri-food market and the challenges it may face. Before we get started, we have a quick poll question to get a better idea of who we have on the call today. Please take a few seconds to answer. A few process comments. We are not soliciting investment. This presentation is to provide information about Induction Food Systems products and services to help them find customers, mentors, and other strategic relationships that can help them grow their business. You are all on mute. You can use the chat window to ask a question. After the formal part of the presentation, we will answer as many questions as time allows. This presentation is being recorded and will be available for replay. And with that, I am pleased to introduce Francesco Amini, CEO and co-founder of Induction Food Systems. Francesco, please take it away.
Hi, everyone. It's really great to be on this session. And thanks, Luke and the iSelect team for inviting me to be here to present to all of you. So Induction Food Systems, we like to say that we're the future of industrial heating, and thanks for that intro. I'm Francesco, I'm the CEO and one of the co-founders. I want to start out by telling you a bit about how food and beverage process heating works today. Right now, we're using steam as the main way to generate and apply heat in food and beverage manufacturing. It might not shock you, or maybe it will, that the same technology was used by Louis Pasteur over 150 years ago when he was first doing his experiments on pasteurization. And we've come a long way in a lot of ways since then, but we're still using steam as the primary way of processing the fluids and foods that we eat. So a bit about steam boilers, if you're not familiar with them. They're typically very, very large pieces of equipment that are installed in large food and beverage manufacturing facilities. These are fixed assets, and steam plants typically do their best work when they're running at steady state. They're providing steam, the steam system's balanced, and it's exchanging heat with specially formed pieces of metal called heat exchangers as a way of putting heat into fluids. But we've come a long way in 150 years, except on the process heating side. In order to do any heating in the plant, you have to have a very large fixed infrastructure that really is optimized for running a single product 24/7, 365. It's meant for operations with long production runs, and it's what we've been using to make the legacy products that are now currently being displaced from the market by younger, more agile, more nutritious, and more flavorful products in the marketplace. Combine this with industrial megatrends that we see along the lines of increasing efficiency and precision of manufacturing. It doesn't take a lot to see that the IIoT, the Industrial Internet of Things revolution, is meant to make manufacturing more efficient and more precise. in the same way that electrification has helped make Tesla cars higher performance. We're also seeing consumers, the base on which the market's built, shifting their preferences toward products that are made more sustainably, have more flavor, and generally have a better for you story behind them. And all of these things are squeezing manufacturers. And as we transition from industry in its current state to what we call Industry 4.0, we see the shift from legacy facilities and processes becoming smaller, more distributed, and more nimble, but not only that, but much more efficient in making product. But there are some real technical barriers to doing that and to making that transition, not least of which is steam. Steam is not a technology that that changes nimbly. It's pretty slow to adapt in terms of plant operations. And every time there's changeover in a production line, you wind up losing product, more importantly, losing time. Because steam heating can't keep up with the pace of production and apply heat to product as quickly as modern manufacturers needed to. It also caps throughput, especially when we're talking about high protein fluid foods. For context, that's things like Yoo-hoo milk, chocolate milk, liquid eggs, or Ensure or Boost energy shakes, which are some of the highest value products on the market. The fixed infrastructure of steam is not very expandable, so manufacturers want to add a fourth line or a fifth line to their facility. They're just not able to do it in a capital-effective way. Despite all of these limitations, manufacturers still spend $20 billion, that's 20 with a B, on outdated heating equipment across the food, beverage, and brewing and distilling markets. Okay, that's a lot of money. And IFS is disrupting this market using NASA-level heating technology. Let me tell you about it. Our solution is what we call middle-out heating. On the screen, you see a cross-section of what our heat applicator looks like. We have an insert that lives inside of a process tube that we energize with electromagnetic energy. Instead of outside-in heating, which most heat exchangers use, we put heat very close to the product, which allows us to get product temperature very quickly and control it very precisely. On the metrics that matter for heating performance, IFS outstrips the competition, from everything from temperature control to responsiveness, in a smaller footprint that is hyper-energy efficient. And we use this heating platform to power the highest value food and beverage applications. These are pasteurizers and sterilizers when we sell them as a turnkey processing system, or in a lighter weight format, which we call trim or booster heating. And these are pieces of equipment that bolt on to existing production assets to make them more efficient and increase yields and uptime. Now, manufacturers look at three major metrics when they look at their plant. How much yield do they get out of it based on what they put in, how much finished product they get, what's their throughput, and what's their overall equipment effectiveness, which is a metric that says, for the time that we try to produce, how much are we actually making? How effective are we at making our product? Depending on the use case and the application, IFS has been shown to increase yield up to 1%, throughput to 35%, especially in high fouling, high protein applications that I described earlier, and for OEE boosting it up to 9%. I know what you're thinking. Manufacturers are going to know exactly what that means, but you might not. So let's put some numbers to it. When we looked at putting a trim heater on a high volume juice line, we're looking at a $250K per year return. And when we look at the high fouling applications like liquid egg, that right now has almost half their time in their day as downtime for cleaning processes, that uptime is worth approximately $3 million. We even heard numbers up to $10 million a year. Okay, so how do we do it? How can you put one piece of equipment in line and get $250,000? We recently did an ROI study with a national juice processor. It's a national brand that's running 200 to 300 gallons per minute through their production line. Our goal was to look at reducing downtime, especially after stoppages in a production line. Stoppages occur for a number of different reasons. it might be you shut down for a cleaning cycle, or more commonly, that you're changing over for a different SKU or different SKU. This might be a different flavor of juice. You're going into a different packaging format on the other end. And this doesn't even count all the times when something doesn't go right on the line. So you might shut down the line if there's a mechanical or electrical problem, either upstream or downstream from the processing system. And every time you shut down a line, you need to bring it back up. And that warm-up time is literally lost. When we ran our analysis with this national juice processor, we were able to take the warm-up time on each of these cycles from 10 minutes and model out an IFS system doing it in a minute and a half. And that's how we get up to $250,000 in uptime per year. I'm going to show you what our system looks like just very briefly. This is a beta prototype of our S-series thermalizer. This is more or less would be bolted on to a production line to do trim heating and booster heating. It's meant to handle low viscosity products, juices, beer, and water. So who else is doing this? Well, the players that do the most for heat exchangers are really great at food specialty, but they don't have induction heating technology. They also don't have the same temperature precision or energy profile that we do. The boiler manufacturers, well, they don't have our technology either. And the people who right now make the induction systems don't do what we do in terms of food and beverage applications. We have no direct competition in the market, and our biggest competition right now is selling into the installed base of steam systems and disrupting a legacy technology. So how do we make money? Well, we sell equipment. We sell hardware, which are either turnkeys or bolt-ons, to manufacturers either direct to them or through channel partners. We also license custom designs of our heat applicators to national brands or global brands specific to their products, as well as realize component sales to other manufacturers, like the Intel Inside model. Along with service and maintenance to get recurring revenue, we also look at software as a service plays in order to do recipe management and IoT analytics. Let me tell you more about the team behind this. I'm Francesco, I'm the CEO of the company. I also wanted to introduce my co-founder, Dr. Sadler. He is the person who literally wrote the book on food processing technology. 35 years as an academic in the industry and a number of patents and articles later, he and I teamed up almost 10 years ago looking at different opportunities. And we founded Induction Food Systems in 2017. A little bit more about where we are as a company. Like I said, started in 2017. The commercialized technology that had first been funded by Dr. Sadler, been conducted by Dr. Sadler, and funded by NASA level research. We went through the Techstars Farm to Fork Accelerator last summer in 2018, and this summer are going through the Plug and Play Accelerator. We piloted last spring with our partner Cargill to assess our beta systems performance and applicability to their processes. We raised around $250K so far, realized our first revenues from piloting last spring, and have issued US IP for our technology. One of the things that gets us very excited about this technology is that it's not only applicable to food and beverage processing. Process heating is an outdated process across a number of large adjacent markets. Oil and gas, specialty chemical, and plastic extrusion are all areas that we've received passive interest from and know that we have a better heating solution. But food and beverage is where our bench strength is and is our beachhead. Over the next few quarters, we are seeking additional pilot partners to look at applying our system to different hot fill production applications. We're also targeting alternative protein as a market to do beta testing and bring a product to market that can boost output for alternative proteins to help them scale up production. We're targeting the beginning of 2020 for our pre-seed raise, and I would love to hear your questions about our venture and our technology. Thanks.
Awesome. Thanks for walking us through that, Francesco. So to ask a question, go to the question window on the right side of your screen. Feel free to type it in, or you can use the hand raising icon, and I'll unmute you, and you can ask in person. So I will kick things off here. A few questions of my own. So Francisco, really interesting stuff that you guys are working with right now. I'm curious to know a little bit more about how the technology actually operates. So I think you mentioned that it heats internally. Is that like a microwave? If you could just speak a little bit more toward what the big innovation is here with induction food systems, I think that would be really helpful for the audience.
So we are pioneering the use of an industrial technology, induction heating, that's been around for quite a while. We're the only ones who are using it in this way for food and beverage applications specifically. The coil that surrounds the process tubing where we're doing our middle out heating is what energizes via electromagnetic energy that insert that lives inside of the process tubing. One of the cool things about induction is that we get to heat metal without anything touching it. And it's all happening with the power of magnets and electricity.
Got you. So it's more of the application of a long-standing technology into a, more proper application of it. Is that correct?
That's correct. We've really cracked the code on how to apply heat in a gentle way that's suitable for food and beverage products in a way that no one else has.
Mm-hmm. And so you said that it ultimately amounts to $250,000, or up to the potential of $250,000 of savings per year. What part of the food processing, value chain is really honing in on the most value there?
So this is definitely for
the quality.
Exactly, and there's a number of benefits for manufacturers depending on the application and what their specific production goals are. For our use case that we vetted in a hot-filled juice pasteurization line, they were most worried about uptime. There are other manufacturers that we've spoken with who are now in talks with to pilot our technology, who are more interested in making sure that they're capturing what would otherwise be waste as part of having a more precise heating system, and others that like the idea of quality and increasing time to temperature as a way of making better food products. And these are all manufacturers that are on the value-added side of production. So after we're pretty far away from the farm gate at this point, and going all the way through the value chain until you're getting to the value-added processing into a CPG product. We've also worked with ingredient manufacturers like Cargill to assess one step previous to the CPG or finished good product to see how we can fit in a little bit higher up in the supply chain.
Got you. And then you mentioned towards the end of your presentation that you ultimately see this technology as being applicable to multiple different markets. Over the long term, do you think that the biggest value add will be in the food system, or could you see a potential future where, hey, maybe this is actually better suited for, gas processing or some of the other possible applications that you mentioned earlier?
We see building a huge company based off of the food and beverage industry alone. Why we named the company Induction Food Systems. We see ourselves servicing those additional markets via channel partners, because that's not where our strength as a company lies, at least not right now. We think food and beverage has the most ground we can cover, because we tend to see the least amount of innovation in the manufacturing process in the food and beverage sector as compared to a sector like specialty chemical or oil and gas.
Gotcha, that makes sense. And then would you say that food that's processed through induction food systems methodology, is it higher quality? Is there a better flavor profile? What would you say is kind of the on the consumer end of things? How would you say that it's really providing value to the downstream user, not just cost savings to the manufacturer?
So some of the testing that we're undertaking now is to look at nutrient retention and flavor and texture retention as it's going through our system compared to other processing technologies. the reason time to temperature is such an important metric for a food and beverage process is the faster you're able to bring something like, for example, orange juice with a lot of pulp in it up to its pasteurization temperature, the more of the orangey flavors, and in the industry they're called organoleptics, the more of the flavors, the hints, the smells, all that stays in the system if you can ramp temperature more quickly. And that's exactly what our system does. And we're doing the preliminary tests on product flavor and nutrition retention coming up this quarter and next quarter.
Gotcha. Awesome, Francisco. So my last question here is, what can the audience help you with there? If you're looking for people to reach out to you, are you looking for other potential investors, strategic partners, people that might be interested in buying this technology? What would be the most help for you at this stage?
It's two parts. The first of which is connecting with other manufacturers who do hot fill production. That's where you're heating something up through a pasteurizer or through a kind of a thermalization process and filling it into a container. So that would be sauces, condiments, juices, and beverages. Connecting with them to continue to do pilot testing in order to refine our technology so we can make the jump to commercial production and a commercial product in Q1 of next year. And it's never too early to start the conversation with people who are interested as investors or have an eye toward that. We'd like to engage with people who have an interest early on so that you can see how we execute on our product and our business development pipeline.
Very interesting. Well, thanks for walking us through the business and technology today, Francesco. This is really interesting stuff. So that concludes our Agrifood Conversations call today. We host these calls every week at 3 p.m. Central on Thursday. You can register for Agrifood Conversations series by going to agrifoodconversations.com. A replay of this webinar will be emailed to you in the next 24 hours. And if you know of others that may want to see this webinar on replay, they can register on the original webinar link to gain access. Thank you for your time today, everyone. Enjoy the rest of your Thursday afternoon.